Now the topic is Newtonian flow. Newtonian has derived one formula. Viscosity is equals to force shear stress divided by shear rate. See, how can we quantify the shear stress? Nothing but force. Shear rate. See, in case of cone and plate, viscometer, this is the cone, this is the plate. I have put a little small amount of sample is required here. Then how much amount of weight I am adding here, then I can call that as a shear stress. So how many RPM it's rotating when you are adding, how many RPMs means how many revolution per minute is going on when you will add or when you will increase the weight. See, for example, I have added 1 gram weight here, then how many RPM this cone will rotate means 10 RPM, for example 10 RPM. When I have increased again 1 gram, 2 gram, then 20 RPM. So it's indicating that upon increasing the weight, the RPM will increase. The RPM means shear rate. Upon increasing the shear stress, shear rate may be increased or it may be decreased. Here in this case the shear rate is increased. So Newtonian has derived one relation. What he has done means viscosity is directly proportional to, say viscosity is directly proportional to the shear stress. Shear stress nothing but force. Say more the viscosity of a liquid. If a liquid having more viscosity, more force is required. More force is required in order to make that liquid to flow. This is the liquid. To make this into the flow, the more the viscosity of the liquid, more force is required to make the liquid in order to flow. This is the relation he was derived. This is the relation he was derived. See another one. Another one, when the viscosity is increases, see when the viscosity of this sample will increase, number of rotations will decrease, means shear rate will decrease. Try to remember, when the viscosity of liquid is increased, then the number of rotation per minute, revolution per minute is reduced. This is the relationship the Newtonian has derived from this formula. This is the basic information. We need to know in reality. So, in case of Newtonian flow or in case of Newtonian liquids, what will happen means, when you will increase the weight, whenever shear stress nothing but in the form of weight. Whenever you will increase the weight, what will happen? The shear rate means revolutions. The shear rate will increase. Like, see, I have added 1 mg, then 10 rpm, 2 mg, 20 rpm, 3 grams, 30 rpm. So this means proportionally increasing of shear strain with respect to shear stress in case of Newtonian liquid. In case of Newtonian liquid, what will happen means proportionally. See, this is proportional. We can call as a 1 to 2, 2 to 4, proportionally. This is proportional. This line, this straight line only we can call as a proportional. 1, 10, 2, 30, 3, 30. See, if 2 is there, then it is showing here, means approximately at 15, then we cannot call as a proportional. 1, 10, 2 should be the 20, then only we can call as a proportional. If it is showing at 15 means we cannot call as a proportional. Try to remember this, proportional. What is the exact meaning of proportional? So proportionally increasing of shear stress with respect to shear rate in case of Newtonian liquid. What are the examples? Means water, chloroform, glycerin. Means solution form. Pure liquids. For example, pure liquids will exhibit Newtonian flow. Pure liquids will exhibit the Newtonian flow. Water, chloroform, glycerin, and so on. Other examples. So this is the shear rate to shear stress. So what, see, in the Newtonian fluid, that is the graph between shear rate and shear stress. Now the graph between viscosity and shear rate. See here what is happening means, when the number of RPM, for example consider 10, 20, 30. Even though if you are increasing the number of RPM, the viscosity of liquid will not change. The viscosity of liquid, see, for example viscosity is, you can consider 2 pies. See here 2 pies. For 30 RPM 2. For 10 RPM 2 only. For 20 2 RPM 2 centipies. For 30 RPM same 2 centipies. See, the viscosity of Newtonian liquids will not rise, or viscosity of Newtonian liquid will not increase or will not decrease. The viscosity of Newtonian liquid always be constant. The viscosity of Newtonian liquid always the constant upon increasing of shear rate, This is the concept of Newtonian flow, Newtonian liquid. Now we can discuss the non-Newtonian.